All right, now we're going to talk about some circle theorems. So notice that we can measure arcs either using our traditional method of measure like centimeters, or we can measure them in degrees. So notice that an intercepted arc matches the central angle. Remember, we also saw the theorem that said if I draw from the circumference to my intercepted arc, then I can also see that this angle, I know from what we studied before that this angle is going to be half of the central angle, so that's going to be 27.5 degrees. So I could also say that this intercepted arc is going to be double the inscribed angle. So 2 times inscribed angle is equal to intercepted arc. So that's one theorem. We also have this idea about chords. So two chords of a circle are congruent if and only if their central angles are congruent. So what we're saying is that if this angle matches this angle, then this chord is equivalent to this chord. Notice that would also mean that this arc matches the angle. So I can measure arc length with angle length. So this arc length, same as this angle measure. Congruent chords intersect congruent arcs. Well, if these are the same length, then their arcs are the same length. That's what this is saying. If we have a chord and draw perpendicular from the radius to the chord, it's always going to bisect that chord. So this will become the midpoint of AB. So AM is equivalent to MB. Perpendicular bisector of a chord passes through the center of a circle. So these two things are the opposite. If we have a perpendicular bisector, we know that it's going to end up going through the radius. So that's what this one is saying. Those two are the opposite of each other, just like these two were the opposite of each other. All right, and the last one, congruent chords are equidistant from the center of the circle. Well, if these two things are congruent, I know that this length would be the same as this length, is the same as this length, is the same as this length. And I could draw triangles knowing that this radius, let's put that in there. If I add this radius and then this radius, so I would know that those lengths were congruent, which then must mean that these are congruent to each other. Whoops, third one there. So that's what this one is saying.